Am I audible? Okay.
Yes, yes,
Am I audible right now? Okay.
yes, yes.
Good evening, friends, and good morning, Professor Anurag Srivastava, sir. Welcome you all to the Gyan course today. Now, I would like to request Professor Srivastava to start today's Gyan course. There is announcement for the participants. We request all the participants to present in the course because it is mandatory for the certification. So that is a small request to every participant. Sir, please, the floor is yours.
All right, thank you. So, good evening, everyone, again. And, I'm going to share slides so we can start from where we left yesterday. So, we talked about, basically a lot of different events. So, let me just quickly review. So, we talked about different parts that we're going to cover in this course, and then we talked about the key way to operate the grid. Situational awareness is very important, and decision support, right? So these two things are very important, which tells us that which state we are operating and what action to make if we are drifting away from the planned operation, right? Then we also talked about automatic control, which is much needed for faster action needed to keep the frequency and voltage within the limit, right? And then we talked about different mode of operation: normal, alert, emergency, blackout, restoration. We discussed different event. There are a lot of event that happened in the past, but few of those, 2003, 2015, and also India 2012. The common thing is that these all start with external environment not being good, right? Which means that weather is not good, or there's a higher load because of summer peak demand, and then it start with one of the outage of line or one of the outage of generation, right? In some cases, the weather is so extreme that also it result into a more impact on the grid, right? So with that, now we are going to talk about some of the definition in operation, power grid operation, and a little bit introduce about the market, because that also impact that how we connect DERs, or distributed energy resource, in the grid, and what's the incentive for that. So let's start from here. First, which is one of the very important performance criteria, is reliability, which tells us that ability of our system to keep supplying all the connected load. And we do have a multiple different indices to measure it, right? So how, and typically reliability is measured two ways. Most of things that is required to be reported is done by observing the system performance for a year and then calculating that how many times outage happened, what was the frequency of the outage, and then computing separate indices like CADI, SAFI, which a lot of different acronym, but basically it tells us that how often outage happen, which is written right here, by frequency of outage, how often it happens, what was the duration of outage, and what was the magnitude of outage. So these three things are important to measure the reliability. Second way to compute reliability is through formulation, which can be done with the simulated data and network information and system information. Typically, it is estimated, it is not a calculated value, and that means that estimated is not going to be exactly the way we expect, right? So simulation based reliability indices is just for planning purpose, which will be not very correct. After the year performance, of course, what we calculate is the true value. There is a lot of different consideration while computing reliability. If at least in US, that we have a policy that if something is caused by a weather event like a hurricane and wildfire, then we don't count that outage in reliability factor, because it will be unfair to compute reliability for a utility and compare reliability with another utility, and one has more and more hurricane coming into that region, other one does not. So there has been certain criteria developed for that, how to compute the reliability. There is a standard for this to compute it, and in this problem there are two functional aspects, which is adequacy and security. Another way, reliability is a result of that how secure you operate, which is basically operational security, not the cyber security, and how much adequate supply you have, right? So it depends on these two things. Reliability to performance, adequacy and security is something that you can do to add and make the system better. Adequacy is all about generation, while security or operational security is all about your system or network robustness. So adequacy is basically system ability to have enough supply to meet the all connected customer demand, right? And we can also measure it that if you have a 1.2 times more demand, more supply than demand, or you have 1.3 times, right? So that's a simple calculation. But also it, all these adequacy measure allow us to keep margin. So if something one fails, how do we know that there's enough margin in the system for maintenance and unscheduled scheduled outage of the system elements? So it's about it's adequacy is about the having enough supply to meet the demand. Operational security or security is about, which we discussed very briefly, that if a disturbance happen and one or two component goes out of the system, can we still be reliable enough? Which means that some disturbance leading to outage of key component is not causing reliability to go down, and that will be security. So security is always about if and then analysis. So a little bit more about security. So it's the ability of a power system in normal operation that even with the disturbance, it will be able to uh, keep the system in alert and normal, but not go into emergency or restorative state when we lose the power, when outage happens. So in this case, we cannot design a system high redundancy, because if you want to make a system secure or operational secure, there is a cost associated with that. Because if outage of one to two component is not causing a problem to have a power outage, that means that you have to have enough redundancy in the system. You have to have more than what is needed, right? Because then only it's possible that outage of one or two component will not cause a problem. And if you want to have more than what is needed, it will cost you more. So given that factor, uh, enabling system security is cost prohibitive, right? So cost is high, and we need to make sure that we only try to become